From the last video, we realized that there are no rational numbers whose square is 2. That is, p square is equal to 2 does not have solution in Q. But there are rational numbers whose square is less than 2. Similarly, there are rational numbers whose square is greater than 2. Let A be the set of all positive rational numbers whose square is less than 2. Why do you think we are taking only positive rational numbers here? Why not negative rational numbers? If you have any idea and justification, please do comment. And let set B be the set of all rational numbers, obviously positive rational numbers, whose square is greater than 2. Now let's concentrate on the set A. Consider an arbitrary element P of the set A. Then P square is less than 2. Then p square minus 2 is less than 0. Here p square minus 2 is a negative number, negative rational number. Therefore, minus of p square minus 2 is a positive rational number, which implies minus of p square minus 2 is greater than 0. Therefore, minus of p square minus 2 divided by p plus 2 is greater than 0. And note that p plus 2 is again positive number because p is positive number. Now add p on both sides, then we will get an inequality. Please note this inequality as 1, and this inequality is p minus p square minus 2 divided by p plus 2 is greater than p. Let q is equals to p minus p square minus 2 divided by p plus 2. This is the number, rational number, we had on the left hand side of the 1. This implies q is equals to p plus 2 into p minus p square minus 2 divided by p plus 2, and continuing this gives you this equation, and then finally it is simplified to 2p plus 2 plus p plus 2. You can see this in the Rudin's book also. This same equation is there. The final what we got now, q is equals to 2p plus 2 divided by p plus 2. You can observe this equation there. And now q square is equals to this one. I'm just squaring on the both side, and then minus subtracting 2 on both sides, and then expanding things. You can pause and watch what happening here. And finally, look at q, the equation q square minus 2 is equals to 2 times of p square minus 2 divided by p plus 2 whole square. Here p square minus 2 is a negative number, and the denominator p plus 2 whole square is positive number. Therefore, our q square minus 2 must be negative number, is less than 0. And please do note this inequality. Note that q is equals to p minus p square minus 2 divided by p plus 2. This is a rational number because p is rational number, and easily we can show that q is a rational number. Now we have q is rational number, q square is less than 2. So what else we need to say that q is an element in A. So q is greater than p. Why? You just look at the inequality 1. In that inequality 1, we on the left hand side we had q. So q is greater than p. This implies p belongs to A. Then there exists a q which also belongs to A such that q greater than p. Similarly, there exists q dash which is equals to q minus q square minus 2 divided by q plus 2, and this q dash is also greater than p, and there is no end to it. That means you pick any element in A, we can find an element inside the A which is greater than this. There is no bigger element or bigger number in the set A. This is what this whole discussion is telling us. Similarly, you just follow the same steps and you start with p square minus 2 is positive number. That means p square is greater than 2. That is what the definition of the set B says there, right? So you do same things and you will definitely get to understand that there is no smaller number in the set B. Suppose s is a number such that s square is equals to 2. Definitely s is not a rational number. By now we have clear information about this. We have set A is equal to set of all rational numbers whose square is less than 2, and set B is equal to set of all rational numbers whose square is greater than 2. Suppose our any element in A is greater than S, then definitely it will lead us to the contradiction, because S square is equal to 2, therefore P square is greater than S square, will takes us to the P square is greater than 2, which is supposed to be P square is less than 2, which is not allowed then inside the set A. So this is a contradiction. If we consider an element or any element in B and P is less than S, then definitely it will lead us to the contradiction that P square is less than 2, because our P square is less than S square and S square is equals to 2. Again, if P square is less than 2, then P is not allowed in the set B, but P is in the set P. So this is definitely a contradiction. Now you take an example of an example element of A, say 7 by 5. It will gives you 49 by 25 for squaring, and then whose value is almost 1.96, which is almost equal to the 2, not equal, almost very near to the 2. Now from our discussion we can find out one more number than the 7 by 5 inside the set A, but greater than A. So we can find out very nearest numbers, and also we can find out as many as numbers, I mean infinitely many numbers in set A itself, but none of them are greater than S. I mean none of them are definitely not equals to S, because S is not a rational number, but none of them go ahead the S. And also the same thing happens in the set B also. None of them will come or will spot in this position such that they are less than the S. So these set A and set B have very compactly packed. I'm not telling that there is no gap for nowadays, which is easy to see, but I'm telling that we can see that by the definition of A, B, and also the discussion of what we had earlier in this video over the A and B. You give any number of A, we can find one more number inside A, but is greater than that previous number. And now it is clearing, we have clear mindset that those numbers, whatever the greatest number you took, those numbers never be greater than 2, because they are the elements in the set A. Similarly, what happening in B, this shows that there is a gap in between set A and B, and set A and B contains only rational numbers. So this shows that if you consider only rational number, there must be a gap. And coming to the earlier question we had in the previous video, that where such kind of numbers exist, where P square is equal to 2, such kind of numbers exist in between A and B, it is looking like that. So we need to adopt one more system, that is new system, which will give some kind of a satisfactory explanation. That a new system is system of real numbers, which is the key principle of the whole real analysis.